Okay, welcome everyone. Excuse me, as I'm sure you know, last week Stephen Hawking passed away at the age of 76. Many of us knew him, had substantial interaction with him, and I will say that over our routine lunch conversation, we began sharing stories and anecdotes about our conversations and interactions with Stephen, and thought it would be nice both for us to continue that sharing and maybe do it in front of a group so that you get some sense of what it was like to talk to Stephen and interact with him. So that's really the purpose of today. It's very informal. We're not going to present a lot of intricate and complex physics, which you'll be grateful to hear, but mostly we're just going to share some stories, and I encourage everyone up here who interacted with Stephen to interrupt. I expect we'll be interrupting each other a lot. And hopefully we'll have an interesting time and learn more about him, both as a scientist and as a human being. After we do this for a little while, we're going to go outside. When Stephen was here in 2006, he planted a tree. He was here for the inauguration of the IAS. That tree has now been replanted since it was before this building was constructed, and we'll go out and have a little rededication ceremony with the tree, and then we'll have some refreshments. Okay, so again, informal, please feel free to speak up if you have questions or something. So I'm just going to start by telling you a little bit about Stephen's background, not all that much, I don't know all that much, and then I'm going to share with you a couple of anecdotes with my interaction with him, and then we'll let some of the other scientists up here talk about their interaction with him. So Stephen was born in 1942 in England. His parents were well educated. They had both gone to Oxford. His father was a doctor. He was a, I think, fairly typical young man in growing up in England. His family was a little eccentric, I understand, and so he had a bit of an eccentric upbringing, but not too unusual. He went to Oxford as an undergraduate, where he initially wanted to do mathematics, but they didn't have mathematics in the college he was in, so he did physics instead. He was not a particularly great student. A story that has been widely reported in the media is that he felt like he didn't have to work at all to do reasonably well, and it wasn't worth his time to do extraordinarily well. It was reported that in his entire undergraduate career, he estimated that he spent no more than 1,000 hours actually studying, which over the course of a 3-year education is not a lot of studying time. When he graduated, he took his final examination, and he had hoped to pursue a PhD in cosmology, which he ultimately did at Cambridge, working with a scientist there named Fred Hoyle. To get into Cambridge at that time for this group, you needed to get a first on the examination, which he did not get. In fact, he got something that was on the boundary between a second and a first, and the system then allowed him to request an oral examination to do better and achieve a first. And he reported much later in life that at that event, he told the committee that if you give him a second, he's going to stay at Oxford and pursue his PhD, and if they really don't want him around, they better give him a first so he can go to Cambridge. They did indeed give him a first. The committee, after the fact, said they recognized how special he was as a student, even if he didn't perform all that well in his classes. And he did pursue his PhD at Cambridge under the supervision not of Fred Hoyle, which he said he was bitterly disappointed that he was assigned to Dennis Sciama, another very well-known cosmologist. While he was obtaining his PhD, he was diagnosed with a serious disease. At that time, it was diagnosed as amyotrophic lateral sclerosis. In the United States, that's sometimes called Lou Gehrig's disease. Lou Gehrig, a famous baseball player who suffered from the same ailment. The standard life expectancy, once you get a diagnosis of ALS, is only a few years. And so he was told that he would not survive. It would be unlikely for him to survive beyond a couple of years. At that time, he seriously considered dropping out of the PhD program, but both his mentors at Cambridge and his doctors advised him to continue, and he chose to continue. He has said many times in his later life that this was a real turning point, not just because of his health issue, but it made him focus and made him begin to take his studies and his approach to life much more seriously. And I think one of the interesting things about him is you can see, those of us who interacted with him, that he maintained a lot of his characteristics that were inbred in him, and you'll hear that in some of the stories we talk about. Stephen went on to live another 55 years, which almost certainly means he doesn't actually have ALS, but some other ailment with similar symptoms. ALS patients don't live that long. If he has ALS, he is by far the longest lived ALS patient. His PhD work was on cosmology. He was fascinated by black holes, and indeed much of his subsequent research, for which he's well known, has to do with black hole physics. In particular, one of the issues that he was excited about as a young man is that black holes in principle are these objects whose gravity is so strong that nothing can escape from them, even light, so they appear black. And deep in the core of the black hole, space-time itself seems to become singular. Now, in fact, no physicist actually believes it becomes singular. The black holes that were discovered in general relativity that were known at the time didn't take into account quantum physics. It was expected that quantum physics would do something to that singularity, but it wasn't well understood what might happen. So Hawking was always fascinated by those singularities and what quantum mechanics might do to help resolve their physics. And so his PhD work was on the existence of those singularities. He proved, along with Roger Penrose, a set of theorems called the singularity theorems, which proved the inevitability of those singularities without quantum mechanics in a variety of circumstances. And actually, his most important contribution at the time was applying it not just to the interior of black holes, but the earliest moments of the universe in what we now call the Big Bang. And we'll hear, I think, a good deal more about that later. Sometime later, Hawking did a piece of work for which he is probably most famous. He discovered that black holes aren't truly black, but they actually produce some radiation called Hawking radiation in quite an astonishing and unlikely way. That Hawking radiation has led to enormous controversy and puzzles in what happens when you combine gravity and quantum mechanics, which continues to be at the forefront of physics today. And again, we may have a little more discussion of that. Hawking had a tremendous influence on science and scientists, on us, but he became quite a public figure and a cultural icon. That was in part due to his great scientific achievements, his disability, but also his personality. He was tremendously open and engaging, and had a wonderful adventurous spirit. He liked to do things, and he really didn't let his physical disability get in the way of anything he truly wanted to do. Sometime in the mid-1980s, where he was not yet the cultural icon that he became concerned about money issues. He didn't feel like he had enough money to pay for his health care at the level he wanted, pay for college for his students, and he decided to write a popular book. That book was called A Brief History of Time. It was, I think, a challenge for him to write it. Already his ailment had progressed to the point that he couldn't speak. He used an artificial device to synthesize his speech. So actually writing and communicating was quite laborious. That book became a wild bestseller. I think it's one of the most popular science books of all time, and really propelled Hawking into the celebrity that we know today. Okay, I think that's about all I'm going to say about his life. I want to share with you a few anecdotes of my interactions with him, and then we'll open it up and talk more. So I first actually saw him when I was a graduate student at Harvard in 1985. He came to visit, and he gave a wonderful talk. At that time, he was still able to speak. However, he was unintelligible without an interpreter. So his graduate students would learn to interpret his speech and would act as interpreters. So he would talk for a few sentences. The graduate student would then repeat it so that we would understand. And he gave a standard colloquium physics lecture in that style. It was really remarkable. Shortly afterwards, he went to visit CERN, the particle physics laboratory in Geneva, and contracted pneumonia. And at that time, he was not expected to survive. But in fact, the story is that his then wife was asked whether they should not use artificial means to keep him alive. And he seriously considered that, but in the end decided to continue to fight. They performed a tracheotomy so that he could breathe more easily. They cut a hole in his throat, standard procedure, but from then on he completely lost the power of speech. He recovered. He went back to England, where he recovered, and for a brief period of time he could communicate only by using his eyebrows to help pick out letters on a board with all the letters, so very laborious. And one of his colleagues in Cambridge managed to connect him with a company called Words Plus that had a method for using finger clicks to select letters and words, and eventually produced the speech synthesis, which I'm sure you've all heard. So shortly after 1985, after he developed this speech synthesis system, it was much easier to communicate with him, although still quite laborious. He could do maybe 10 words a minute. So it would take rather a long time, and you'd be waiting anxiously to hear what question he wants to ask you, and it would take a few minutes until he would craft it. The next time I met him, I was a graduate student or maybe a postdoc at the Aspen Center for Physics. So this is in a small mountain town in Aspen, Colorado. It has for 50 years had a small organization that hosts physicists to come and do physics research. It's very rustic, very rural. And I was just a student. I didn't know anything. This is in the late 80s, before there were cell phones. There was a time before cell phones for the young people here. And there were no phones in the offices. There was one phone for the whole campus with maybe 80 physicists. And I was there on a Sunday afternoon, and I was the only one there. Everyone else was out hiking or doing something. And the phone rings, and I answer it. And it's one of Stephen's assistants saying he's arriving at the airport. Someone has to go meet him. And I'm a graduate student, I'm terrified, and I see another physicist that we all know named Tom Banks come walking across the campus, and I say, Tom, here, take the phone, and I throw the phone at him. And he says, sure, someone will be there, and he hangs up the phone, and he says, you, go to the airport. So I arrive at the airport, and I'm just terrified, I have no idea what's going on, and so Stephen at this point is using his voice synthesis, and he has already programmed it for many, many canned phrases so that you don't have to wait. So, he can say, hello, how are you, that kind of thing. And I started to have my very first conversation with him. And I remember it very clearly because I was interested in, the Hawking radiation and that kind of thing. And he had... So I was talking about it, and there's a phrase that's very common in popular physics books, and Hawking used it in his book. It's called spooky action at a distance. You ever heard that? Yeah. About how quantum mechanics works. And so I used that phrase, and then he clearly had already programmed something into his synthesizer. So he presses the button, and immediately comes out, anytime I hear spooky action at a distance, I reach for my gun. Somewhat later at Aspen, so I became a regular participant in Aspen, and in 1995 we organized an event with the Aspen Music Festival. There's a very prominent music festival for young musicians in Aspen. We organized an event where Stephen would introduce his favorite musical compositions. So he was a lover of classical music. In fact, sometime after he was diagnosed with his ailment, he began to listen to a great deal of Wagner. And so Wagner appeared prominently on the program. He would introduce, using his synthesizer, all the pieces of music. And I think the Wagner piece was the Siegfried Idyll, if you know Wagner. And I remember very clearly he's introducing the piece, and you can hear his pre-programmed thing, and his synthesizer and his famous voice is saying, this is one of my favorite pieces, the Siegfried Idyll by Richard Wagner. And he then repeats it, Richard Wagner. And he then, he has this thing pre-programmed, and he says, I hope I live long enough that they can actually make a synthesizer that doesn't say Richard Wagner instead of Wagner. The last anecdote I want to tell is around the same time, I'm at the Physics Center speaking with some other physics friends of mine. One of them, Sidney Coleman, a great physicist who passed away a few years ago, was my thesis advisor. And we were talking about all the things that we might like to do. And earlier that day, a group of young physicists had gone bungee jumping. You know what bungee jumping is? These elastic cords, and you go on a cliff or a bridge or a tower and you jump off. So they had come back from bungee jumping, and I was asking Sydney how he feels about this. And Sydney says, I would never want to go bungee jumping. I would be terrified. And right when he says this, Stephen comes rolling by. And he looks at us, and then we're waiting, and there's some synthesis going on, and 2 minutes later he says, point me in the right direction. And he actually didn't go bungee jumping. But just as an indication of what Stephen is like, I forgot to mention, Stephen was here in 2006 for the inauguration of the IAS. We have proof he was here. Michael was here at the time and helped host his visit, so we may hear some stories about that. So he didn't go bungee jumping, but famously in 2007, the year after he visited here, he went up in this plane, which is affectionately known as the vomit comet, where the plane goes into free fall for a very brief period of time so you can experience weightlessness, which is kind of the appeal of bungee jumping as well. So famously, Stephen did this 8 times, and as you can see, rather enjoyed himself. Okay, I think I've spoken long enough, and maybe Henry has a few things he'd like to share.
As most of us who's not Stephen's students, the interaction with him is always relatively brief, but it's something that memorable to each of us. So I worked a little bit on the cosmology in late 1970s, early 1980s, which sort of overlaps a little bit with Hawking's interest. He has 2 interests, as Andy mentioned, is that he and Penrose worked out some singularity theorems following from general relativity. And singularity happened inside black hole, and he wanted to understand that. And singularity also happens as you go back in time. Our Big Bang theory is going to hit a singularity, or at least appears to hit a singularity. And so he's also interested in the origin of the universe, what happened to the singularity, if it's there or not. So those are 2 areas that he has dedicated his life in. And in the late 70s, early 80s, when I was a postdoc, I work on that. So, but then I moved out of that, and so I have no interaction with him after that. So with the interaction, actually, I'm very happy to say, is that he wrote an important paper where my paper was the first citation. So for postdoc was, very happy about that. Then I did something else, and then late 1990s, I came back to work on cosmology because I look at string theory. There's a way to explain some issues or propose some issues in cosmology. So I came back to work on it, and then from the 1999, and then for the next 10 years or so, I was invited to Cambridge to Stephen Hawking always organized these kind of conferences or workshops. I think I was invited every other year because I think the other year is black hole. So I think he's doing black hole cosmology way. And the nice thing about it is that when Hawking invites you, you go, okay? So every time a lot of prominent cosmologists around the world will be there and then give us a great chance to interact with each other and, of course, to meet Stephen. The only incident I can remember is 2, maybe. One is lunchtime. Steve came over, and he was put in a wheelchair. In the 20s, he's already really very difficult to communicate already. So he's through this synthesizer. And so whatever to do, he has to type out. So we were having freewheeling conversation of 4 of us and with him. And then we'll talk about topic to jump. It's like a typical lunch with your friends that you talk about people, you talk about politics, and you talk about science, jump topic. And then all of a sudden, click, he wants to say something. And then we wait, and finally he type up something, and then read out, and we wasn't sure what he's talking about. And then we realized that 3 topics earlier, he's responding, okay? And it took us a little while between us to figure out what he was trying to say. And typical, as usual, when you want to say something, it's always deep and profound. But he also is known to be blunt. And I think we all have experience. partly because he cannot have a long message. He always answers yes, no, or one or two words. Okay, and one of the conference, one of the prominent cosmologists explained his idea, and then at the end, actually privately, but immediately the word spread that Hawking thinks that prominent cosmologist's work is, one word, garbage. And so I gave my talk today, and Hawking usually attended all the talks. And at the end, he wanted to say something. That room is about 100 people or so, and immediately everybody was quiet. Wonder what he's going to say. I can tell you I'm pretty nervous because if he used the same word, there's no chance I can respond or reply. Okay, so fortunately, after a while, he typed up. He just asked a question, wanted to clarify some point. So I was totally relieved from that. And I never have a one-to-one conversation with him. It's always with some other scientists or his students or his former postdocs. And it's always scientific. And it's clearly that whenever you touch science, you have something not agree with him, he got very excited. He has a very strong opinion about his own work. Then one thing that overlap a little bit is that if you have read a book, A Brief History of Time, that Hawking wrote, he talked about no boundary proposal that he has with Harold Hawking. And the idea is, and he'd be pushing it, so suppose that the universe is described by a solid oblate object like this, okay? There's no boundary. But if you take any point on the, if you take any point and say this is the, suppose you take this is time direction, you take any point, then clearly that's like a singularity. So you appear as a singularity. You take any point as starting point, this is space-time. Of course, the picture is only a cartoon. But you take any point and then go ahead, and as if universe is beginning, and as if they appear as singularity. But in real life, there's no singularity. So original he and Penrose worry about singularity issues. He thinks that his proposal actually resolved that. And he's been very excited about that. But his proposal actually follows from inflationary idea that people have a few years earlier. And he embraced that right away. And essentially, that universe started like this. Of course, the other half we don't know yet. We are only here. That's 13.7 years. But essentially, this picture is motivated him to come up with a no-boundary proposal for the origin of the universe. Okay? And of course, George will talk about why we believe this, since George played a crucial role in this scenario. So the only other encounter with him is probably in 2006. He came to Hong Kong. I was out to give a lecture in preparation for Hawking's visit. Then we went to Beijing for the string conference. That's actually the purpose he came and the purpose I came. And so at Beijing conference, the week after, we happened to be sitting at the same banquet table. But in China, if you know, the banquet table are very big. You can only talk to the person left and right, not across the table where Hawking is sitting. So I talked to my wife is on one side, and the other side actually is Dennis Overby, a New York Times reporter. And I can tell you that Hawking ate everything. Every dish come along, they just cut little pieces, and then he will eat it. Okay, he wear a bib. So half the food go to the bib, and of course, we understandably that the best he can do. So, and then my wife wanted me to, hey, you should have a picture with Hawking. And I said, no, I'm not a fan. I'm a physicist who don't believe in being a fan of his, because then you can't argue with him, right? So we always sometimes like to have some disagreement and things like that. So then she said, okay, she'd like to have a picture. And we asked a lady who's taking care of Hawking feeding, and Hawking said, sure, yes. And that's the picture. And actually, the lady asked, does Steve want to cover his throat? If you look at all these pictures, he's covered his throat, okay? And they said, no, it's okay. And actually, it's really, he has a whole tool for make sure that something breathing problem, all the things. And clearly his life is very, very tough life, but he put a great enthusiastic about life and very, very inspiring to all of us. And I think you should be inspired. You think you're tired, you have a headache. Hey, look at Steve Hawking. He is suffering much more, and yet once you talk about science, he can forget everything else and get excited about it. And that's very, very inspiring to all of us. So, thank you.
You can go next, but I wanted to just jump in. So, there was always this, when you would talk with him, you'd have to wait because he would be constructing his sentence, and it's very nerve-wracking because you don't know what he's going to say. And I think Henry said that he's wondering. He gives this talk. Hawking's going to ask a question. He's wondering what is going to come out. Is he going to say my work is garbage or something? For me, if he said my work is garbage, I'd be so proud. Hawking read my work. That would be the takeaway.
All right, so I was going to ask if they were going to go first because my relationship with Stephen was very different from everybody else's, as I was an observer and he was a theorist, and my work was relevant to his work and vice versa. And in fact, it was very important that a paper by his thesis advisor, Dennis Siama, got me very interested in cosmology, which was actually not a new field, but a revolutionary field because the Big Bang had just emerged. The Big Bang, 65 was the radiation was discovered. 66, Hawking is writing his thesis about cosmology and the singularity in cosmology. But what he's done, if you look back, you'll see he did what other people had talked about, and he did it with much more precise mathematics and clarity of what's going on. But come back to that. But because of the paper that Dennis wrote, which I could read and understand, he did a follow-up paper where he got it much more qualified, which I could not read and understand at the time because even though I knew a little general relativity, I couldn't read it at the level that he had written the paper at. But the two of them had written this paper that said basically if you measure this radiation of the Big Bang, you could see if the universe is rotating, right? So one of the things we talk about in why we have inflation, we talk about making the universe uniform and all this kind of stuff. We don't talk about the fact that we get rid of any intrinsic vorticity and so forth. Those are actually one of the pieces of evidence you would have, but what you don't. But anyway, that was one of the things that I thought, well, this is cool. You can make these measurements, and that how it got me in the field, and that's how we ended up starting being in contact. But let me go and talk about the other side of Stephen. And I found this really important when I was young, to see people who I knew from their life experience had been great scientists and to realize that they were humans too and that they weren't so unbelievable that I couldn't do what they did, right? I might not be as good as them, but at least I could try and do what they did. And so one of the things that happens is you got to know Stephen on a different form than the theory talks and so forth, is you realized that he is very human. He tried to live, even though his life was difficult, a very normal life, even though he was unbelievably restricted. But he was a lot more adventuresome than most people. And so I will tell you about one of the times, and then depending on how much time, we'll come back to more or do not. So around 2006, 2007, he came to Berkeley one of several times that Stephen came to Berkeley, or we met him other places. But he specifically came to Berkeley for various reasons. In 1988, he came and got an upgrade in the synthesizer and so forth. So it's a different story. But he came there, and he was coming to give a talk and a popular talk, and we were doing work and everything. But he arranged that we would have a private lunch together because he wanted to ask my advice on certain things and talk about certain sensitive things. And this was a chance for basically a one-on-one, but you never did anything alone with Stephen in those days. They don't show it right. There was always a postdoc, and there was always either a nurse or an assistant there with him. And when you had a conversation, it was always 3 conversations going on at once. And so one of the things is Stephen was always paying attention to everything, even though he was typing. So there was multiple levels of things going on. I was conversing with his grad student or his postdoc, and sometimes with the secretary or his nurse about what was going on, and carry on a conversation with Stephen because there's this big time delay. So it was this complicated thing. But he came to ask me a question, and it was the question you would ask experiments. The first question, he had 2 or 3 questions. But the first one was that Richard Branson had asked him if he would go and take one of the flights on Virgin Galactic. So I don't know if you know what Virgin Galactic is because it's way behind schedule and everything. But in 2000, it was supposed to be starting to be, for tourists to space. And they made tremendous progress, and then they ran into some problems. And just like they had, the Virgin Airlines and everything, he wanted to make it possible for me to go in space. And Stephen very much wanted to go weightless, but he knew that I of the Sturz friends, I didn't know how to do this stuff, but he knew that I could give him good advice on rockets. And I said, so I started out in this thing, I really want to go to space. So I'm trying to figure out how can I hook a ride with this, because I want to go too. Says, but rockets are actually quite dangerous. I think I'd wait for 100 flights before, before I thought it was safe enough, that it was reliable enough that it's going to come down, because things can go wrong and things can wear, and you want to see what's going on. So, a month or so later, it's announced that Stephen is going to go on Flight 99. Okay, so he had to go, up on me a little bit. So that happened several times. I went on The Big Bang Theory. He went on The Big Bang Theory. And then he went on 3 other shows, so on. But then I said, all right, well, there's something that I can help do for you for your birthday, because he was coming up to be 65. And I said, we can arrange, that's the picture you were showing, we can arrange for you to get to 0G first so you can see what it's like. Because he wanted to go, the reason he wanted to go in space was in it, but he wanted to be in a situation where he would be a normal person. That if it doesn't matter what kind of muscles you have in 0G, if you're floating, you're floating. It's a kind of thing like that. And I said, well, I happen to know, Peter Diamandis and Ray Kurzweil, but Peter Diamandis and 2 other people had started the 0G company, which is separate. NASA had been running the what they call the Vomit Comet, so it's got the name. But he had started this company some years before, but I happened to know him because we were doing another project, Singularity University together. And so I put him in connection, and I said, we'll try and arrange for your birthday. Well, it took a little while. His birthday is in January. He didn't fly till April. But he got the opportunity to fly, and as Andy was saying, he loved it. And it was complicated because the way it works, there's a little bit of undergraduate physics. The way it works is you do parabolic arcs, right? So if you throw something under 0G, it makes a parabola. But when you go down the other way, you get 2G, right? So Stephen Hawking is floating, and a short time later, he's being pressed down at 2G. So there was a question whether we do it. And so he had to get approval from their doctor and his own doctor that he could withstand that. And they also had to arrange it. And Peter said, this is great, just like Richard Branson. I'm getting a lot of publicity for this. So there was this negotiation about it's got to be covered on TV. Peter's going to go on there, and the assistant and 4 doctors, 2 from each side, had to come on this thing. And they did that. And they were going to try they do a couple of things, and if that was okay and they evaluate it, they would do some more, right? And of course, Stephen loved it and thought it was great, and even got them to do a flip. If you actually go and look up the video, you will see him do a flip in 0G.
Yeah, the video's on YouTube. It's easy to find.
Right. And so it was just, he thought that was like the greatest thing that ever happened. And unfortunately, Virgin Galactic isn't galacticing, or whatever it is, or even near Earth orbiting, or not. It wasn't even going to near Earth orbit. It's not it was just to go up and come back down. But anyway, he was very eager to do that, and he was willing to take the chance, right, to do that kind of thing. But he wasn't totally crazy, right? He wasn't willing to go on Flight 1, which I wasn't either.
Half crazy.
He was half crazy.
Yeah, I mean, you said it right. He famously once said, someone asked him, do you feel like there's things that you can't do because of your disability? And he said that the only things he can't do are things that he had no interest in doing anyway. And this is an example. If he wanted to do it, he would go do it. He would make it happen.
So there were a number of things like that I saw him do. And we were talking about other things. And in the middle of this meal, he gets a call from his daughter, right? And so his daughter, Susan, and they're co-writing a book. And the publisher is taking advantage of the fact that Stephen is out of town, gives her a deadline on signing on the dotted line to publish this book by such and such time. And so he, being there at the table, and it's on the speakerphone, you get to hear both sides of the conversation. You see that, but he's being a dad, right? And he's teaching his daughter negotiating skills and how the viewpoint. And you could see how very normal this kind of activity is going on. And we're having a long lunch. It's a 2-hour lunch. He eats 6 oysters. He likes oysters because it turns out you don't got to chew them or anything. You just got to swallow them, right? I mean, it's a if they're raw oysters. And so there's this whole long sequence of things that are going. We're talking some about science, some about other things, mostly about these kind of questions, including him being upset about the Nobel Prize. So we had some discussion about what it would take for him to get it and what not to. And so he was ambitious. He was really interested in a lot of things. He was, he wanted to do more things in life. One of the reasons that I think he lived so long is that he fought hard. I mean, he really was ambitious in the sense he wanted to live longer and get things done, and he wanted to make sure that he left behind achievements. And when he got diagnosed with the disease, it focused him from being sort of a party enjoying graduate school, undergrad and graduate school life, to trying to get some accomplishments done, trying to get things done that, relate to leaving some kind of legacy or making some kind of achievement. And he cared about that, and he cared about doing that. And so sometimes when there are things I try and discuss with him thinking this is good or not, he wasn't paying attention to it because he was sure he was on the right track. So this no boundary, I try to convince him there should be gravity waves from inflation. He said, there's not, discussion done. We're moving on to the next topic, right? That's the kind of thing that happened. But he also had a wicked sense of humor.
Oh, yeah.
Now, garbage, usually it's at least a 4 or 5 word phrase, but he could stick the knife in pretty good on people. And but he really tried to live a normal life and do things and not let things get in the way, and yet accomplish all these things and enjoy himself. And he did. It's just a lot of. It's very kind of like that. So I had another. I don't know if my picture's ever made in here or not. Yeah. So I had there's a picture which I'll talk about some of that. This is shortly after he got a voice synthesizer that gave him his robotic voice, which he actually copyrighted, and he's using this old synthesizer for a very long time, and the equipment was failing after 25 years, and so they've spent 2.5 years making a new voice synthesizer that still sounded the same as his old one, except it's much higher quality. It doesn't have the noise behind it. And he only got to use it for about a year, and then he died, unfortunately. But they spent a huge amount of time doing it. This is another picture. You should have a lot of pictures of me with him, but we're doing an event at the African Institute for Mathematical Sciences in Cape Town, 2008. And then we went over to Stellenbosch where there got to be a great new theoretical physics center, and we were doing a thing for that. And so we had some time to talk about various things there. And he was concerned that Cambridge was going to force him to retire because the laws were you had to retire at 65 or 67, and he was coming up to it, right? And so he was absolutely psychologically convinced that Cambridge wouldn't make him retire. But we talked about the various things. What would people do? How do you, how do you handle that? Because he wanted to keep working and keep doing things, and so he wasn't just going to stop and quit. It's he had more things that he wanted to do and more things that he was interested in trying to study and understand. And in the meantime, he did taste the wine because that region is a very famous wine growing region in South Africa. And he wanted to go out to see some of the wild animals, which you can do. And I think they did go out eventually. I don't know. I went to a different area after this, so we can see. But so I had several different situations. So there I'm standing up. We were at a press conference, and I'm standing up making a point, and he is being bored or typing in the background. I'm sorry, I should have. I should have asked him for pictures with me, but I'm just like Henry. I didn't think to sit and pause for pictures with him. There we were just sitting and working, and somebody took a good picture, and so we'll see. And I thought I would show you one more picture because I don't want to talk too long, and then at the end maybe I have some other events I'll say. But let me show you the boundary universe. Okay, so in 1970, so his thesis in 1996. It was about the universe, and the last chapter was about singularities in the universe, where he took some early ideas of Penrose and made them into a chapter and his thesis. And if you look in there, you will see that. You'll see the chapter before he made some mistake in, and they just crossed it out in his thesis, because typing it again and writing it by hand was, you didn't have computers in those days. It's a kind of thing. And but here is the idea that there would be a singularity at the beginning of the universe or at the end of the universe, or both, and they make boundaries in space-time. And so you're used to the idea of a black hole. A black hole is something that forms and goes forward in time. It makes a boundary in time. There's a boundary in there you can't cross. But for the universe, there would be a boundary at the beginning of the Big Bang, and if there's a big crunch at the end, there would be another boundary, and so forth. So this is a universe that has a boundary. And one of the things that happened sometime between 74 and 70, because he had done the Hawking radiation when I first met him sometime at one of these conferences, he took some of the data we had about the from the cosmic microwave background and came up with a discussion saying, we've proven that there had to be a singularity at the beginning of the universe because we've shown the universe was uniform to a part in 10,000. You extrapolate the universe back 10,000, and then the energy density of the radiation itself is sufficient to cause it to collapse, right? And so I got a discussion with him about that, and the reason is our limits weren't quite that good. That was close to what we had, and he didn't care. He didn't want to hear that because he already knew the answer now. And it was another few years, like another 4, 5 years before we get to that kind of limit. But that was the kind of discussion. When you look at that, what you realize is that the universe has some sort of a beginning, a boundary. It goes up, and it might have a boundary on the other side, but black holes can form, so you get that upper right picture where you got a boundary, you got boundaries starting up, and then they all end in a major boundary. That's a universe with a boundary, and that's messy. You'll see how much messier the diagram is than that beautiful sphere that Henry showed you. And that's why I think he made this big jump to the no boundary universe. It's both because it matches to inflation, because this is a lot prettier picture than this, right? And mathematically, it's a very interesting kind of thing. But he eventually abandoned that, right? And so we'll see that. It's a kind of a thing. It's sort of, he held on to some ideas for a long time, but then he did give up on them at some point because we're progressing. So I think I'll stop, let the next person have a chance to say, and then we can talk about. I mean, there are other instances of things that I had with Stephen, but those are the kind of examples of the, there were practical everyday things. You want to fly in 0G, right? Well, how many of you guys want to fly in 0G? How many of you guys have done it? Right? Okay, and you don't want to retire. How many of you guys have had to retire? Well, Henry and I are coming up against the limit, so we've tried to find ways around it, right? But he's been an example to us.
I said just comment because Michael's not ready. Last December, I got invitation to go to a cosmology workshop at Albania, where co-organized by Hawking. And the definition of co-organized by Stephen Hawking is that all expense will be paid. Every single trip that I was invited, and every participant was totally paid. And we realized one time is that he can always find a donor to donate the funds for the whole workshop. And occasionally, I was told that he would put in his own money in order to make sure that it's a very successful conference or workshop. So this is very, very amazing actually contribution to just the community in cosmology. So, unfortunately, it was canceled.
There were problems.
Okay, first I thank Andy for inviting me to talk here because I am a bit different. I do not have too much personal contact with Stephen Hawking, but instead my contact is with him in 2006 when he arrived in Hong Kong to hold the inaugural lecture for IAS, and I guess that's the first lecture that was offered in the name of IAS, so it's a great event. This is the first slide I gave in the talk organized by the School of Science in that year. And so you can see there's nothing wrong with the date. But I'm not going to give the hour-long talk. I just extract some of the slides to give you a more personal impression. Especially, I think he's a great communicator in science. The first thing I want to, as Andy and Henry and George has talked about, is his contribution in black hole. And at an early stage, Stephen did not understand, and I guess many scientists did not understand, and that's about the nature of the black hole, and there's something called information paradox, because we know that when matter fall into black hole, then it will become a very simple form. And so if you have a lot of things that have information, it will fall in a black hole. That means the information will disappear, right? Those who know physics probably will know that information is associated with entropy, and probably those who learn thermodynamics would know that entropy of the universe will continue to increase. And so this is a paradox. Will information disappear? So a lot of people did not have this idea, right? And so these are some of the early attempts, and I don't think I'll have time to spend on that. But then there was a big debate, and this was called the Hawking-Bekenstein debate in 1972, and it was extracted from the internet, and you can see how intensive the debate that is, and you can see how strong is the standpoint of Hawking. The other side is Bekenstein, also another famous physicist, and he's also a tough guy, right? So we can see from this conversation, right? So Hawking said the analogy between these things is just a matter of coincidence. But then Bekenstein said, I am not convinced. Nowhere in the universe is the second law of thermodynamics violated. Why black hole is an exception? I believe this is actually the second law of thermodynamics is still uphold. And then an interesting thing is Bekenstein's thesis advisor, another very famous physicist, Wheeler, and then it seems he tried to stand aloof from this debate. Your idea is just so crazy that it may actually be true, right? So, but then Hawking still maintained his point of view. He said if black hole has entropy, it must have a temperature. And if it has temperature, it must radiate like a black body. But if nothing can escape, how can it radiate? So that was the viewpoint when he started, before he introduced quantum mechanics into his studies of black hole. But then after he started to introduce quantum mechanics into black hole, he find that his view has to change. He find that black hole actually has a radiation, and actually it can radiate. And nowadays we call this the Hawking radiation. And so he's willing to change his point of view once he realized that the truth is not what he originally thought. Then he would start to switch, right? And so he looked at this from a humorous way. And so we know that Einstein has a very famous anecdote. He said, God does not play dice with the universe. That was referring to his unwillingness to accept quantum mechanics. And then at that time, Einstein was having a debate with Bohr, and Bohr said, Einstein should not tell God what to do. But then Hawking, after he find out these Hawking radiation, he said, God not only play dice, but also sometimes throw them where they cannot be seen. Right? So I guess that was referring to black holes. Right? So he do have a lot of wit and a lot of sense of humor. Now, another thing that I want to mention is he liked to make bets, and I like to mention several bets. Right? So this is a bet with another famous physicist and Nobel laureate, Kip Thorne. Now, at that time, people were discussing observation of black hole, and there was a Cygnus X1 that was observed on the sky, and nowadays people believe it is a black hole. But at that time, while the experimental evidence was still accumulating, people start to be sure, but not exactly sure that that Cygnus X1 is a black hole. And so what Hawking said is, well, I believe it is a black hole, but I want to have a insurance policy. That means in case it is not a black hole, then at least I will win a bet. And so he make a bet with Kip Thorne and saying that I bet that it is not a black hole. And then he has this document ready with his signature. And then his prize is that if Kip Thorne win, then he'll get 1 year subscription of Penthouse magazine. And then if Hawking win, then he'll get another subscription of another magazine. Why Penthouse? I'm not sure, but I guess you know that this is his way of getting attention, and probably if you mention Penthouse, more people will get attention, right? So he has a way to communicate science, and then making interest in that. And then there's another bet. This time is with he now sign up with Thorne, and then make a bet with Presco, and it's called the black hole information paradox. Again, another on black hole, right? So what he's betting is when information fall in the black hole, and then it will be completely lost. We will never see it again. But Presco believed that, well, black hole is difficult to understand, but eventually some form of information will come out. And so after that, they do further study, they make a bet, and then finally Hawking again lost the bet. And then he accept that maybe black hole can still transmit information in a garbled form, maybe a garbage form, maybe. And so another bet, more recent, is he bets that scientists cannot find Higgs particle, and so this time he lost $100, right? And so, but then his remark is, okay, if that's discovered, then the standard model is confirmed, and this physics is less interesting, right? So what I have to convey in this few minutes is that he has made contribution to the theory of physics, and he has an open-mindedness, as you can see he's making bets, and he has a very broad attitude towards life, open attitude, and he has a very eagerness to popularize science, as indicated by his book, and all these bets. And so I guess this is the time we need to remember this great person. Thank you.
So I'd like to take a little bit of time to share my personal memories about Professor Hawking. So the first time I saw Professor Hawking was also, as mentioned a lot of times, 2006. At that time, I was first-year graduate student in Beijing, the Institute of Theoretical Physics, and my supervisor was one of the organizers, well, not the major one, but one of the organizers of the String Conference. So I helped to do a lot of labor work for that conference. And I still remember he gave a public talk. I was unable to focus a lot on that public talk because I have a major work of that during that talk, that there was a amateur scientist sitting next to me, and I was trying to persuade him not to ask too exotic questions. So I was not focusing very much. But nevertheless, And the next time I indirectly encountered him was quite a few years later, probably 3 years later. I have a longtime collaborator, Dr. Xingang Chen, and he was at Cambridge at that time, known as the Hawking Fellow. And so I often talk with him through Skype or telephone. And after he moved to Cambridge, I noticed that over the phone, there is a pretty mysterious background noise, something like a fax machine, like dee, 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 this kind of noise, as mysterious as the cosmic microwave background radiation. And then Xingang told me that because his office was next to Professor Hawkins' office, well, technically, actually, next to Professor Hawkins' team's office, because there is also a technician office in between. Yeah, but nevertheless, so when Professor Hawking operates his computer, so from time to time, there is such a noise. So yeah, that's what I heard. And a few years later, so Xingang left Cambridge for his faculty position, and it happens that I took his position and also his office. Yeah, so I was living with that. Well, that's fine, and it's pretty much an honor to live with that. And I have to say that I didn't personally talk to him a lot because considering his physical situation, I was too nervous to tell him anything which he considered to be garbage. So yeah, so just something like, hi, or morning, Stephen, this kind of talk. So Professor Wang told us about the information paradox. So if I throw all the messages I talked to Professor Hawking into a black hole, that's not going to cause an information paradox because that contains no information. But nevertheless, so I was close to his office, so I'm really impressed by him, in the sense that considering his physical situation, so he was at his office from morning till evening, so probably even longer time than I'm in my office. And also he gives all kinds of speeches when there are events in Cambridge, and he has a great sense of humor when he's giving the speeches. And he comes to a lot of seminars, probably every of them that he has time to attend. And indeed, the speaker of the seminar feels very nervous, like Henry said, so Hawking may give some comments. And actually, because Hawking sometimes operates his computer and he controls using his eyes, so it's not so accurate. Sometimes he may happen to make some voice, which he doesn't intend to make. And occasionally he says no. And the speaker got frightened, but actually it's just some random noise. But nevertheless, I think he enjoys a lot of talks. And so I was really shocked when I hear the news that he passed away, because so despite his physical condition and his age, so I feel he really has a young spirit. So my feeling is like he's going to live with us forever. So I was really in deep sorrow to hear that. And so although he's confined in his physical condition, but he really gives me a feeling that he's actually a young man. Yeah, that's all I want to share.
Well, thank you. I think that's actually quite a good way to end this session. It's about 4:30. We've talked a lot. So I think that one of the most remarkable things about Stephen, in addition to the tremendous science that he did, is that he wanted to experience everything in life, you know, from the ordinary to the most exotic, and he didn't let anything stand in his way. He was a family man. He had 3 children. He was married. He was divorced. He did all sorts of crazy things, but as George said, he wasn't totally crazy. It was well considered. He was an adventurous spirit. He had a tremendous wit and humor about him, and I'm sure all of us will miss him terribly. Anyway, thank you all for coming. I think we're going to walk outside to where the tree that he planted in 2006 has been recently replanted, and then we'll have some refreshments. Thanks very much.